Mathematics Class 8th, Chapter 3rd, Exercise 3.1. Understanding Quadrilaterals, question number 2nd. How many diagonals does each of the following have? Number A is a convex quadrilateral, B is a regular hexagon, C is a triangle. New terms appearing here, diagonals. First of all, let's try to understand what a diagonal is. A diagonal is a line segment connecting two non-consecutive vertices of a polygon. Line segment, we have discussed about it in question number 1st. You would like to watch it. Let's give a simple description. When we connect two given points with the shortest distance possible, it gives us line segment. And it says connecting two non-consecutive vertices. Vertices is a plural form of a vertex. And what is a vertex? The meeting point of a pair of sides is called its vertex. It simply means, consider we have side AD and AB. Wherever they meet, they are meeting at point A. So it would be called as a vertex. And plural of that gives us vertices. Therefore, what is a diagonal? If we consider vertex A and we try to connect next non-consecutive vertices, let's find non-consecutive vertex from point A. Here, D is not the non-consecutive vertex. It is consecutive. By consecutive, we simply mean immediate next. So we cannot connect point A and D, that is vertex A and D, with a line segment. If we try to connect, it would be just a side itself. Or the other way to connect vertex A and D would be like this. Well, it loses the definition of diagonal. A diagonal needs to be a line segment, whereas it is not a line segment, because line segment is the shortest distance between any two given points. Therefore, we cannot consider it as a diagonal. That's why it is not possible to connect two consecutive vertices in order to make your diagonal. So a diagonal is a line segment connecting two non-consecutive vertices. The important point here is non-consecutive vertices. That is, if we are considering point A, we have shown you that vertex D is a consecutive vertex. Henceforth, let's check for vertex C. C is non-consecutive, because if we try to join point A and C with a line segment, it would be something like this, from A to C, and it is the shortest distance possible. Therefore, it is a diagonal. Here we tried to make you understand that a diagonal is a line segment that is the shortest distance connecting two non-consecutive vertices of a polygon. And you know very well what is a polygon. Polygon is a closed curve entirely made up of only line segments. With this understanding, let's try to find out how many diagonals does a convex quadrilateral, a regular hexagon, and a triangle have. First of all, let's construct a convex quadrilateral. We just learned in question number 1st what is a convex quadrilateral. So let's try to construct the same. First of all, we made a quadrilateral keeping in mind that its internal angles need to be less than 180 degrees. So if you consider all these angles, that is angle A, angle B, angle C, and angle D, these all angles are less than 180 degrees. Therefore, they make a convex quadrilateral. And now let's try to construct diagonals and find the total number of diagonals. So let's try to construct diagonals from vertex A. We have shown we cannot connect A and D. That would be side itself. So we are going to connect A and C. That would be something like this. So we have constructed one diagonal. Now let's try to construct diagonal from point B or vertex B. Vertex C, consecutive vertices of vertex B. Therefore, we cannot connect them. Here, vertex D is non-consecutive and we can connect like this. Now let's try to connect from C. Well, when we tried to connect from point A, C took care of itself. That is, this diagonal is common to A and C. Likewise, when we constructed a diagonal from point B, it touched vertex D, which is common to both these vertices, that is vertex D and vertex B. Henceforth, we can only construct two diagonals if we are given with a convex quadrilateral. Therefore, 2 is the answer for A part. Now let's try to draw a regular hexagon. So what is a regular hexagon? By regular polygon, we simply mean polygon which is both equiangular and equilateral. Equiangular means all the internal angles are equal. In case of hexagon, it is 120 degrees, that you know very well from your previous standard. And equilateral means, equi means same, lateral means sides. That is, all sides are equal in length and all internal angles are equal in measure. Now let's try to construct diagonals. You know very well we cannot construct a diagonal through consecutive vertices. So let's try to construct from this vertex S. we cannot construct to T and R. So we can construct from S to U like this, S to P like this, because they are non-consecutive vertices that we are connecting. And finally from S to Q like this. So we can write from S we have constructed 3 diagonals. We would add some more diagonals which we will try to construct now. Let's shift our focus to vertex R. From R we cannot construct to S and Q because they are consecutive vertices. We can construct to T, U and P vertices from vertex R. So let's try to construct the same. It would be like this, R to T, then from R to U like this, and R to P like this. So we have constructed from R 3 diagonals, so we can write 3. Now we would add more diagonals to it, so we wrote plus sign. This is just for easy remembering. From our vertex Q, one is already been constructed when we tried to construct from vertex S. We cannot construct to R and P vertices, so we can only construct to vertex U and vertex T. So let's construct the same. So to T from Q it goes like this, and from vertex Q to U it goes like this. So we have constructed 2 more diagonals, so we wrote 2. We are going to construct more, so we wrote plus. So from vertex P, 2 are already drawn, and only possible vertex that we can draw diagonal is from P to T, because we cannot construct from P to U and Q. That would be consecutive vertices. So let's draw the last one, that is from P to T like this. So we have drawn 1 more. No further diagonals can be drawn that you can visualize very well. So we have constructed all diagonals, that is line segments connecting 2 non-consecutive vertices. Now let's add them up. 3 plus 3 is 6, 6 plus 2 is 8, 8 plus 1 is 9. Therefore answer for B is equal to 9 diagonals. Now the C part, that is a triangle. We constructed a triangle. Well, if you observe carefully, we cannot construct even a single diagonal. Because if we consider vertex T, then vertices F and E are consecutive to vertex T. Similarly, if we consider F, D and E are consecutive to it. And likewise, if you consider vertex E, vertices F and D are consecutive to it. That is, we cannot find any 2 non-consecutive vertices that we can construct inside a triangle to construct our diagonal eventually. Therefore, in a triangle, we cannot construct even a single diagonal. Therefore, answer for C equals to 0 diagonals. So you see how easily we can construct diagonals. The only thing is we have to remember its definition. That is, a diagonal is a line segment, that is shortest distance connecting any 2 points, with a condition that this line segment can only be constructed within 2 non-consecutive vertices of a polygon. With this, our question number 2nd of chapter name Understanding Quadrilaterals, Mathematics Class 8th, chapter 3rd, question number 2nd has been solved.